Hello guys. So this video is about similar figures, and this is something that is used a lot in engineering as well, and you learn it in previous courses. But the general concept is this: if you have this rectangle, for example, and you have this rectangle, and this is A, B, C, and D, and then you call the small ones A, B, C, and D as well, and you know they are similar, then you can say that BC is related as BC as, for example, AD is related to AD and is the same as AB or BA is related to AB and is the same as CD is related to CD. That's basically the principle. You could even say that the distance AC is also the same ratio as the rest AC, or this one here BD and BD, like that. You can say all of that in that part. You're not seeing here this part, but I wrote here AC. And if you have triangles, same thing. If you have this triangle and this triangle, and they are similar, then this angle is going to be the same angle as here. This angle is going to be the same angle as here. And you're going to have the same relation. This side divided by this side has to be equal to this. The reason for this is, for example, let's call this side C, A, and B. And let's do the same thing here, A, B, and C. What you are doing in reality is comparing the angles when you have triangles. For example, what is the tangent of alpha for this angle? Tangent of alpha will be opposite divided by adjacent, A over B. And in this case, what is the tangent of alpha? A divided by B. So basically, you know the tangents has to be the same because it's the same angle. So you can say AB, A divided by B has to be equal to A divided by B. And then you can move this in any direction and say that A times B equals A times B, like that, and find any type of relation. Same with beta. You can compute beta. You can use sine, cosine, tangent of the angles. In other words, this side divided by that side has to be equal to this side. This divided by this has to be equal to this divided by this has to be equal to this divided by that. And that applies to plane figures. That applies to polygons in the space also. And that has a lot of uses in engineering. For example, let's say that you have this triangular, which in our case usually is a triangular load, distributed load like that, and then somehow you have to find how much is the height of the triangle at this point. Let's call this y. I don't know how much is this height here, y. So then, once again, in reality, what you do is that you know this angle alpha, right? If you look closely, you're gonna have this small triangle where this is y and this is 4 and this is alpha, and you're gonna have also this big triangle, the exterior one, where this is alpha, this is 5, and this is 4 plus 3, 7. Now you can perfectly say that y divided by 4 is equal to 5 divided by 7, and you can solve for y, which is 4 times 5 divided by 7, and 4 times 5 divided by 7, 20 divided by 7 is 2.86. That's one way to do it. There are several other ways to do it. I can say also y divided by 5, for example. Y divided by 5 has to be equal to 4 divided by 7. And at the end, you see, this goes to this side. Y equals 4 times 5 divided by 7, which is the same thing that we got in the other one. Let's try a different one. I'm going to put all of the examples in one. So let's say that you have now this part and you want to calculate this h here. as I said, there are always several ways to do that, but what I do when I do this type of problems is this. I draw a line here, and then I focus on these two triangles, this triangle and the other triangle. I have this small triangle here, and then I have this other big triangle in the other side, if I see the exterior triangle. And obviously they are similar triangles because this angle is the same angle for both. So if you do that, and I know this is 2, this is going to be 2 as well, the distance. And I know that from here to here is 3.5, but I know this is 2, then this distance is going to be 1.5. And I know also that this distance is h, and this is 2, so this is going to be h minus 2. And there you go. Suddenly you have the same problem that we had before. You have this triangle, alpha, 1.5, 2.5, and then you have this other triangle here, where this is h minus 2, this is 4, 2.5 plus 1.5, 4, and then you start working your similar triangles. You can say the easiest way for me at this is say h minus 2, this side divided by this side has to be equal to this side divided by that side. And then you solve for h minus 2 equals 1.5 times 4 divided by 2.5. You pass this multiplying to the other side. Now this you pass it adding. 1.5 times 4 is 6. 6 divided by 2.5 plus 2. And that is 6 divided by 2.5 plus 2, 4.4. There you go. Solved. Now, in statics, you're going to have problems, for example, like this one. Okay. Then you have these type of problems. And it happens that you have this force F3, and this force F3 has these components, this, and that. And you know the values of the force because you calculated the force before. This is the magnitude. Remember, the force is represented as a vector. It could be like that, or it could be ijk. But I know this is going to be in the x direction, meaning in this direction. So this value will be this one. And in the y direction, this value will be that one. And in the z direction, this value is negative because the positive direction is up. So, but it doesn't matter. We're treating it like distances now, like that. So you have this polygon now of forces. But at the same time, I know these distances. I have this polygon of distances. And I don't know this distance, and I don't know that distance, but I know this one here. This is 3. That's the statement of the problem. And in this particular case, I have to solve for x and for y. That's what the problem is asking me to do. Then I can do it in multiple ways. But if those two figures are similar, because they are, the geometry is proportional here to the force polygon. So I can say 3, this distance, divided by this force has to be equal to this distance divided by this force. Once again, comparing the sides of the polygon, and then you can solve that and solve for y, and y will be, you pass this multiplying there, 3 times 213.81 divided by 263.26, 2.44. That's that distance in y. And then in x, if you want x, well, then you can say x divided by this has to be the same as, now you can use this if you want to, this divided by that, or you can keep sticking with 3 and say 3 divided by 263.26, and then you pass this multiplying over there. You pass this multiplying over there, and then you get x equals 3 times 170.45 divided by 263.26, and that will be 1.94. And because this is meters, this is going to be meters, and this is going to be meters. So there you go, guys. Some applications of similar figures for engineering, and I hope that you like it, and I'll see you later. Have a good day.